Okay guys, broadcasting the solutions to lab 2.2. Okay, initial battery test, you got some theoretical voltage that should have been 1.5 volts because that was what was on your battery. You should have got some actual voltage. I'm not sure what that is. And really, the percent error calculation, if you did it, it should be actual minus theoretical divided by theoretical. So it is whatever you actually got minus 1.5 volts divided by 1.5 volts multiplied by 100. And that's going to give you a percent error. Now it's totally possible to get a negative percent error. That means that your actual value was lower than your theoretical. If you got a positive percent error, that means that your actual value was greater than your theoretical. Either way, theoretical values are always what's on paper or given. Actual values are always what we get in the laboratory. 6. These were alkaline metals. Anytime you see alkaline, that's short for the alkaline earth metals. When you look on your reduction potential chart, it really includes all except radium. That's the only one that is not on the alkali on the reduction potential chart. Okay, so we got our lemon battery here, labeling the anode and the cathode. That would make the copper here the cathode, and that would make the iron here the anode, because the copper is higher up on the chart. We know that the cathode is the positive side of the battery and the anode is the negative side of the battery. And there's Mr. Salsa. I'm going to talk over Mr. Salsa, everybody.
Casey Duffy.
So, write the oxidation half reaction. So, at the anode, we have Fe0
and Leah Vanderhyde
going to Fe2 plus 2 electrons.
And also, the following students need to meet in the SAC room right after school.
I'm talking larger than you, Mr. Salsa. So that's going to be a negative 0.4 volts. And the reduction half reaction is going to be
Jennifer Jones, Bennett Lee, Jonathan Ma,
and for copper, that's going to be
follow up on today's drill. Overall,
0.34
how it went. Again, it's always good to practice a mass evacuation of the school in case we ever did need to.
Calculate and record the theoretical voltage. So
E
cell equals negative
solution is for
Eox
before we move you out as the
plus E reduced. That's going to be negative,
but again, your cooperation, most important thing in that situation
plus
is
0.34.
quiet,
So that's going to be 0.4, so that's going to be
phone to call everybody out.
0.78
Please make sure you
volts.
see it with your
So that's
glasses and with your
0.78
teacher at all
volts.
times.
You're going to hook it up,
to track you,
and you're going to get some actual voltage, and you're going to calculate your percent error.
With how the students did today. We will have a fire drill coming up, but I won't say you when. But again, it was good for us to practice evacuating and knowing what we need to do and improving on that for the next time. The attention will be immediately right after school in the dining hall. Enjoy the rest of your afternoon.
Next question. Okay, we're going to make batteries. So this first one involves iron metal reacting with copper 2 plus Cl minus going to Fe2 plus Cu0. Cl is the spectator. If you see the lemon battery, this should be the exact same equation as the lemon battery. Theoretical voltage, you should be able to see above. We're going to draw and label this battery. Okay. The salt bridge is going to contain Na plus Cl minus. This is going to be Cu, which is the cathode. And whatever you got here as your voltage is what you're going to put there. And that's going to be Fe. That's the anode. Okay, and electrons are going From anode to cathode, this is going to be an Fe2 plus Cl minus, and this is going to be an Cu2 plus Cl minus. Okay, your actual voltage is going to be whatever you got there. See the lemon battery for how to do this calculation. Next reaction, Zn0 plus Cu2 plus Cl minus goes to Zn2 plus Cu0. Cl is my spectator. The oxidation reaction is going to be Zn0, Zn2 plus 2 electrons, and the reduction half reaction is going to be Cu2 plus 2 electrons goes to Cu0. This is a very, very common reaction. So we're going to calculate E cell, which is going to be negative E ox plus E reduced. Zn is oxidized, so it's going to be a negative 0.76. Copper is reduced, so we're not going to switch that. That's going to be 0.34, equaling 1.10 volts. So that's the theoretical voltage of 1.10 volts. Draw and label this battery. 10 volts. I'm going to have my anode, which is going to be negative, and that's going to be Zn, and that's going to be Zn2 plus and Cl minus, and that's going to be connected via Na plus Cl minus to Cu2 plus Cl minus, and inside that is going to be the cathode, which is going to be Cu, and everything's going to be connected. Electrons are going to be flowing. If you put the Cu on the left side, electrons would be flowing to the left in this battery. The actual voltage, we don't know. See lemon battery for how to do this calculation. I still want you to do it, but just see the lemon battery for how to do that. And you do not have to do this, guys. So in looking at this lab, the real important thing is to be able to draw a reaction. Okay. From that reaction, calculate E cell. Notice that we flipped the E oxidized value because everything on the reduction potential is for reduction. So we flip oxidation. We have the battery. It contains a salt bridge. It contains the two solutions with their identical metal immersed in them. These symbols should always be the same. It contains the electrons flowing from the anode to the cathode. It contains the voltage value and the anode and the cathode labeled. Take care, guys.